All right. So here we want to find the linear equation that passes through the 2 points, 416 and -2, -2. So the first thing we need is the slope. I always like putting the larger y value first, but whatever floats your boat. So we will get 18 over 6, which is 3. And now you get to pick, just like with when these are in table formats, you get to pick whichever one of these 2 points makes you happier. I'm going to pick the 416 specifically because it's easier to see which one goes into the correct positioning. I know with -2, 2, it's like the same number, so it looks like they go in the same spot. So we'd have 16 equals 3 times 4 plus b. So is that me or? Okay, I don't see any problems. Okay, so subtract the 12 on both sides, you'll get that b is 4. So your equation you're looking for is y equals 3x plus 4. Questions, concerns about that? Okay, cool. So before we start into these notes a bit more, I do want to say something really quick about quizzes, and I also need to fix something really quick. So there's been a miscommunication, and part of it's because I didn't realize how Blackboard handles it, which is my fault. So let me undo this real quick. So you do have a time limit on quizzes, but it's unofficial. And what I mean by that is it's not actually going to be a penalty if you go over the time. The reason I put that up there is because I want not only you, but also me to understand when you are taking quote unquote too much time to finish the quiz. So exams, which your first exam is coming up in 2 weeks, so not this next week, but the week after. But your exams will be officially timed. So you will have 60 minutes. It's a 50-minute class, so I give you an extra 10 minutes in case. You shouldn't need it, hopefully, but it's there in case. But that's officially timed at 60 minutes, and after those 60 minutes, it just automatically submits. Like you don't get a chance to continue. It's just gone, and what you finished, and what you didn't, you didn't. But with the quizzes, you can continue on past the time limit. So with the quizzes, it's like if you're taking more than 20 minutes, you should probably take that as a sign of you need to study that material a bit more before the exam, because if you're taking too long on the quiz, then you also might not finish in time on the exam. So that's why the time limit is there. And so, of course, you probably know that the time limit appears up there. If that's like really freaking you out, you can always make it go away by just clicking on this little arrow over here. But then what I didn't realize happened is that at the end of the 20 minutes, this message comes up and it looks like you just have to submit if you don't read it super carefully. But if you click the cancel button, you can keep going. So you can take as much time as you need. Hopefully you don't take a ton of time. It shouldn't be taking you hours or anything like that. But if you need an extra couple of minutes, you can take that. It's no penalty on quizzes. You can continue. You just have to realize that you have to click cancel on this little box that pops up when the time runs out. I will also be putting out my English is breaking. My words aren't working. I'll be putting that up as an announcement on Blackboard, just in case, someone's not here or they missed it or something like that. So everyone knows it and it's officially stated somewhere. So that's the thing. You can take as much time as you need on quizzes. Just realize that you need to hit cancel on the little box. So I'm sorry about any potential miscommunication on that. I was not aware of how Blackboard handled that. I thought it just kind of let you keep going without making you click a button. Anyway, so we're moving on to our next set of notes, which is the applications to economics notes. So if you've taken an economics class, this is going to be like baby economics. We're not really getting into a lot of proper economics, but we are going to talk about cost, revenue, and profit. And that's kind of be a reoccurring topic in this class, cost, revenue, and profit. We're going to talk about it here. Once we get to derivatives, we'll talk about it some more. Once we get to integrals, we'll talk about it some more. So it's just something that we're going to continue to develop as we go through the actual calculus, we're going to talk about how the calculus then will relate to these cost, revenue, and profit functions. So here we go. Definitions. The cost function, which is usually given as C of Q, gives the total cost to produce Q items. There are two types of costs. There's the fixed cost. This is the cost associated when you haven't produced any units yet. And then there's the marginal cost. Now, the marginal cost is also sometimes called the variable cost. Usually I will say marginal cost. I believe most of the problems you will see say marginal cost. But if you see the phrase variable cost, or I accidentally say variable instead of marginal, they're the same thing. Now, if cost is linear, which is what we're going to be focusing on at first for a while. So if cost is linear, then the marginal cost is represented by the slope. And the fixed costs are represented by the, I'm going to call it the vertical intercept. And I'll put in parentheses the y-intercept because I know that's how a lot of people like to think about it. But with these cost, revenue, and profit functions, it usually doesn't have x, y. It's usually p, q. So I just want to make sure that we're remembering that it's technically a vertical intercept, not always a y, because our variable might change. So we'll talk about it a bit more in this problem, but just to leave it up here so people can write that down if they need to, I'm going to start babbling a little bit. So the fixed costs are essentially, again, what you have to pay no matter what. You know, it might be the cost to rent your building. It might be the cost of the equipment you need to make the stuff that you want. It might be labor costs, you know, that kind of deal. Whereas the marginal cost is essentially the cost that you need to actually make that next item. So if I'm like knitting mittens, I'm going to keep going back to this example of knitting mittens. If I'm deciding to just knit a bunch of mittens, then I need knitting needles. But that's not something that I will need for every single, I won't need a new set for every single pair of mittens. So the cost to buy those knitting needles would be in the fixed cost, whereas the cost of like the yarn or the wool or whatever I'm using, that would be the marginal cost because that's going to be an additional cost for each other pair of mittens that I make. So we go on this first example, goods R Us has a cost formula of 9876 plus 0.5 Q to produce Q goods. What is their fixed cost and what is their marginal cost? What might each cost represent physically? Be creative. So start with fixed. Let me leave myself enough space to write down the marginal. So here, since we have a linear function, it's going to be the y-intercept. Excuse me. One second. Sorry about that. So the fixed cost will be our y-intercept, our b value of the marginal of the linear function. So that'll be our 9876. This could be, and I kind of already mentioned this, it could be a rent for a building. It could be for utility bills or other bills. It could be for labor costs. It could be for equipment. Essentially anything that you need before you even start making any of the products that you're making. So this could also definitely depend on what type of items you're making. You know, if you are making mittens, you will need something to knit or crochet or whatever the mittens with. If you're making radios, you probably need something a bit more mechanical. So it definitely depends, and you could write down a bunch of stuff depending on what good you want to talk about. But those are kind of the more generic pieces that we would need. And so the marginal here would be our slope, so that would be the 0.5. Very low marginal cost there. So this could be, and really there's not a lot of variability here. It's pretty much the material cost. Material, or maybe I'll say labor per job. We'll see an example in a second of someone mowing lawns and it costs them, you know, gas and maintenance and stuff like that. So there's also, it says sorry. Essentially, it's any cost that's going to be reoccurring for each new thing that you make. So then our revenue function, which is usually denoted by R of Q, is going to give the total revenue received by a firm for selling a quantity Q of some good. Now, I hate using the word revenue in the definition of a revenue function, but essentially it's just how much money do you make by selling that many items. So the one thing that we really want to remember for revenue, this is going to come back every once in a while. I'm going to say, what do we know about revenue? And this is what I'm talking about. Revenue is price times quantity. Or I'll usually just abbreviate it P times Q. So price times quantity. Oh, one other thing I want to say. A large majority of the time, these cost, revenue, and profit functions will be a function of Q, meaning that the Q values will be acting as the X values. And I do want to clarify that that's not always the case, so you want to be slightly careful. Usually these are either P or Q. Is it in terms of quantity or is it in terms of price? And whichever ones it's not in terms of gives you the other value when you solve for it. So it's always in terms of price and quantity. It's just which one is a function of the other may change depending on the question. So on the quiz, you know, there was a table and it said something like P is a function of Q, or I think it actually might have been the other way around. But anyway, that doesn't matter. So that would give us that P equals F of Q. Whereas if it said Q is a function of P, it would be Q equals F of P. So just know that it's not always in terms of the quantity. It's going to be in terms of the quantity like 95% of the time. But every once in a while, we'll change it up. And these cost, revenue, and profit functions will suddenly be as a function of price instead. But anyway. So I'll wait like 5 seconds. Hopefully everyone's got that down already though. And our last type of function that we're talking about right now is the profit function. Now that's usually denoted by pi of Q. I don't officially know why it's pi instead of just capital P. I assume it has something to do with making sure it's not confused with probability because P is often used for probability. But if you write capital P of Q for profit function, I will know what you mean. It's perfectly fine. Don't worry about having to use pi if pi is a really hard symbol to find or something like that. But it's usually denoted by pi of Q and is calculated in the following way. So profit is equal to revenue minus cost. So of course we can write that out in our function notation if we want. Now this makes a lot of sense, and the order very much matters here. So if you calculate cost minus revenue, you will be wrong. You will have the correct numbers, but they will have the wrong sign, and it'll just screw everything up. So make sure it's always revenue minus cost. And if you ever forget and you really need to try to remind yourself, think about this kind of logically. The profit is the amount of money you actually get to take home and like keep for yourself, right? So of course the revenue is going to be the amount of money you made by selling those items. So you have this like large chunk of money that you've made that day, but then you still have to pay the bills and your workers and all that jazz. So out of the money that you made that day, you still have to pay some people some money, but then whatever is left over is what you get to take home. So if you ever forget which way it goes, try to talk yourself through it. Okay, well, it's the revenue, it's the stuff that I start with minus what I have to pay people. So revenue minus cost. And then the break-even point for a company is where the profit is 0. Now I want to make a few more notes about this break-even point. So profit being 0. So if we go back to kind of how these are defined. So if profit is 0, but profit is equivalent to revenue minus cost. If I essentially bring that cost function over the other side, I have that revenue equals cost. So actually to find a break-even point, you kind of have two options. You can either set the profit equal to 0, or you can set revenue equal to cost. They will both find you the same answer. Personally, if I have the profit function, I usually use that. If I don't have the profit function, then I will usually not take the extra step of finding it and just set revenue equal to cost. Whatever you prefer is fine. Is that a question? Just saw someone unmute themselves. No? Maybe? No? Okay. The other thing I want to talk about in terms of this is break-even point. I should have added some space at the bottom of this, but I forgot. The break-even point is made up of a price and a quantity. So sometimes they might just ask for break-even quantity or break-even price, and then you just find the one. But when it says break-even point, it's actually it's composed, I should say, of two different values, a price and a quantity. And I'll talk about that. We'll do a question there in a second, looking at that. So let's say we've got our problem here that Ted wants to start up a lawn care business. It's going to cost him $12,000 to buy all the lawn equipment that he will need, and it's going to cost an average of $4 per job in gas and maintenance. Ted will charge $50 per job. So the first thing we're asked to do is to find the revenue and cost functions here. Try to leave a little bit of that in. So cost and revenue here. So at this point in time, we're assuming everything is linear. So as we go on, we will develop more types of functions and get into more complicated types of things that aren't linear. But at this point in time, all we have is linear functions. So all of our functions right now are going to be linear. So for our linear cost function, we need the fixed cost and the marginal cost. So what's the cost that he has to spend no matter what? That's the $12,000. Even if he doesn't mow any lawns, he's got to get that equipment. So we have the fixed cost plus the marginal cost, which is $4 per job. So it'll be 4 times Q. And the marginal cost is the slope, so it should be attached to a variable. Whereas the revenue is the amount of money he's going to make. So if he charges $50 per job, price times quantity will give us 50Q. And that's it for revenue. Revenue is my favorite because it's usually pretty easy. For these linear ones, at least. Now in part B, we're asked for what is Tim's marginal revenue and marginal cost. Now I technically only defined marginal cost, but we have equivalent definitions for marginal revenue and marginal profit. It's essentially the slope of the revenue function or the slope of the profit function if they're linear. And it's essentially going to be the revenue or profit associated with each new thing you make. How much money do you make per item? How much profit do you make per item? So we can talk about marginal whatever. It's not just restricted to marginal cost. So here our marginal cost would be our slope of our cost function, which would be 4. And our marginal revenue would be our slope of our revenue function, which would be 50. Or again, you don't always have to think about it as slope. It's just the cost of making the next item, or in this case, the cost of doing one more job. So the cost per job was $4. And then what's the revenue per job in this case is $50. Then we're tasked with finding a formula for profit. So we need, I'm gonna drop the Q's for a second because they're getting a little tedious. Just in the revenue minus cost piece. So we have 12,000 plus, oh, no, that's not right. What am I doing?
No.
I just did it backwards. So we have revenue, which is 50Q, sorry, minus, whenever you write the cost function down when you're calculating profit, put it in parentheses. Put the cost function in parentheses. Put the cost function in parentheses. One more time. Put the cost function in parentheses. If you don't put the cost function in parentheses, you're most likely going to get the wrong answer because you're probably going to forget to distribute that negative, and then your numbers are going to be off. So essentially what we have here is we have 50Q minus 4Q, just to write it out in full generality before I reduce, which will produce 46Q minus 12,000. Again, if you didn't have that parentheses, you would either end up with 54Q or you would end up with plus 12,000 depending on how you wrote your cost function. So make sure when you're calculating profit, put the cost function in parentheses. Questions so far? Okay. What is Tim's marginal profit? So again, we can talk about marginal in terms of anything. What is the slope of the profit function we just found? It was 46. So our marginal profit is 46. So essentially for each lawn he mows, he's actually able to take home $46. That might go towards paying off the $12,000 of the fixed cost by any means. But technically that's $46 that he can do whatever he wants with. What is Ted's break-even quantity? So remember, break-even, we have the two choices. We can either set profit equal to 0 or we can set revenue equal to cost. Since we have our profit function here, I would just set that equal to 0. So I would just personally set that equal to 0. So add the 12,000 over to the other side. I don't know why I wrote 4 and not 46. Divide both sides by 46. You will get a number that I don't know off the top of my head. What is it? 260.87. Now, technically, if you put that on a quiz or an exam and I didn't specify to round, that'd be correct. I'm going to be a bit more logical here and say someone would probably get mad at me if I only mowed a 0.87 of their yard and say that he should probably mow about, or whatever the heck he's doing, I guess technically, lawn care. Whatever lawn care he's doing. About 261 lawns, let's say. Again, I would accept either, unless just be sure to read my instructions. That's the main reason, that's the main way to know what I want in a question. If I don't specify rounding or decimal places or anything like that, you can just write the answer. If I specify, then you'd need to do what I asked to get it right. Anyway, now I'm going to take this a step further and ask us something that we weren't actually asked here. Because notice here it said break-even quantity. So I can technically stop because it didn't say break-even point, so I didn't need the break-even price, but we're going to find it anyway. Find the break. Can I spell? Break-even price. Now to find the break-even price, you're going to plug the quantity you just found into either revenue or cost. Now, notice I didn't say profit. If you plug that Q value into profit, you're going to get 0 because that's the point. What we mean when we say break-even price is I essentially want to know how much money does he have to put in? How much does he have to pay? What is the cost? And how much money does he need to make in revenue to break even? I want to know that actual amount that he needs to bring in / the amount he needs to put out in cost before it will break even. I usually like to plug it into revenue because that's usually the easier function. Now in this case, I will actually go back to using that exact answer. So if I plug this into our revenue function, that would be 50 times the 260.87 will give us 13,043 and 50 cents because this is money. So essentially, he has to make just over 13,000 in revenue, and it's going to cost him just over $13,000 before he'll actually start making actual profit. So actually, I should clarify, that's exactly what this is kind of saying. The break-even quantity is essentially how many things do you have to sell, in this case, how many jobs does he have to do before he starts making actual profit. Like technically I said he was taking home $46 every job, but he's got this $12,000 bill hanging over his head from the equipment that he had to buy. So this is essentially saying after, or in this case, when he does 261 lawns, he will finally be able to start making actual profit and no longer have to have that cost bill hanging over his head, if you will. He'll be out of the red, if you will. So that's what the break-even point kind of means. That's why it's important. It's how many things do we have to sell? How many jobs do we have to do before we actually start making actual decent profit? Questions, concerns on that? All right, I will give you like a minute and a half to try problem 3. So we've got this person who wants to start an online business selling paintings. She has to pay $12 to get the domain for the website. Each piece she makes will be sold for $75, and her supplies for the piece, so supplies for each piece, will cost $35. Find me cost, revenue, and profit. I'll give you a minute and 30 seconds. All right. Cost, revenue, profit. So our cost function will end up being 35Q, 35 plus 12, $35 for the supplies per painting, $12 for the price of the domain for the website. She's selling them for 75, so our revenue will be 75Q. Making our profit 75Q minus, in parentheses, 35Q plus 12, giving us 40Q minus 12. Questions, concerns about that question? Or about cost, revenue, and profit before we move on to a slightly different topic? Similar, but not quite the same. Okay. As always, if you're trying to type a question and I start to move on, just keep typing it out and I'll go back, but not seeing anything so far, so we'll move on. Come on, scroll down a little more. There we go. So we've got the supply curve for a given item relates the quantity Q of the item that manufacturers are willing to make per unit time to the price P for which the item will be sold. And the demand curve for a given item relates the quantity Q of the item that is demanded by consumers per unit time for the price P for which that item will be sold. I'll try to say that in a bit more modern English in a second, because I find that phrasing a little confusing if you don't realize what it's trying to say. And then the equilibrium point is where supply and demand are equal. It's very similar to the break-even point, where it's kind of like, you're setting two equations equal to each other. Break-even point, you have cost equals revenue. Equilibrium point, you have supply and demand. Also note that this is another point. So it's made up of a price and quantity again. So supply and demand, essentially, say I go back to my making mittens example. So I'm going to make some mittens. And I need someone to supply me with the yarn. the wool, whatever, the yarn I'll say, to make my mittens. So I go to someone who's selling yarn and I say, hey, I'm going to start making mittens and I need you to give me some yarn for it. Oh, here's a question on this one real quick. Let me pop back here. Do I prefer the expanded or the reduced? I prefer the reduced. So I would prefer the 40Q minus 12. I will accept the 75Q minus 35Q plus 12 by all means. I will accept that because it's correct. But if you're asking what I prefer the one that's reduced. But both of them are technically correct, so you can write whichever one floats your boat. I will say that reducing can help with, the question in the future. Like if I ask you the profit function and then immediately ask you to find the break-even point, it's easier to just have the reduced form of the profit function. But technically, up to you. Is that a question or a random unmute? Okay. So back to what I was saying. So I'm going to this lady, I'm asking her to give me lots of yarn for my mittens. I say, hey, so I'm going to sell these mittens for $50. She goes, whew, that's pretty steep. So if you're going to sell them for that much, I'm only going to give you enough yarn for 100 mittens. And I'm like, okay, just kidding. What if I'm going to sell them for $25? And she's like, that's a bit more reasonable. Okay, I'll give you enough yarn for 500 mittens. So it's like, how much is this person that I need the stuff from? How much are they going to supply me with compared to how much I'm going to sell them for? Whereas the demand is, I essentially go out to the public and I'm like, hey guys, I'm gonna start selling mittens. And I'm like, they're gonna be $50, and people look at me like I'm insane. And they're like, okay, well if they're $50 mittens, you're only gonna sell 50 of them. And I'm like, okay, I'm just kidding. I will only sell them for $25. And they're like, okay, I guess I can deal with that. Then we will buy 125 mittens. So essentially, that compares the price that I'm selling them for to how many are actually going to be sold, how many are going to be demanded by the public. And the point is, and the main part that this equilibrium point is trying to reach is that the point is you actually want these values, these functions, to be as equal as possible. You want these numbers to come out to the same thing. Because if you think about it, if they're going to supply 5,000 mittens. If they're going to supply 5,000 or the material to make 5,000, if they're going to supply enough for 5,000 mittens, but I'm only going to sell 3,000, I'm going to have 2,000 mittens sitting around somewhere collecting dust. And that sounds like it costs me money and I don't like that. Or if they're going to give me enough for 2,000 mittens, but 5,000 people want mittens, then there's 3,000 people who are sad that they don't have mittens. And that's also sad because that's more money that I could potentially be making, but I can't because I don't have enough yarn. So you really want to try to make these numbers as even as possible. So looking at our first question here, we've got the supply curve for a given product is going to be Q equals 600p, and the demand curve is given by Q equals 33,000 minus 500p. This is another situation where it's usually in terms of P and Q, and sometimes the Q is solved for and sometimes the P is solved for, so it can depend on the question. And in this case, we're kind of going to cut off the price. We're going to keep it between 0 and 60 just for this situation. So at a price of $10, what quantity are consumers willing to buy and what quantity are producers willing to supply? Will the market push the price up or down? So let's look at our supply versus our demand. So our supply, which one was that? That was the 600p. So we'll have 600 times 10. So that'll give us 6,000. So they're willing to supply 6,000 or enough stuff to make 6,000 of whatever it is we're making. We're not actually told. And then demand, 33,000 minus 500 times 10 will give us 28,000. So this is a situation where the demand is higher than the supply. So we only have 6,000 to give, but we only have 6,000 to give, but 28,000 people want it. So there's going to be quite a lot of people who are upset that they don't get whatever this product is. So essentially what that would mean is this would push the price up. Be pushed up. Because actually, if you look at these functions, the supply function is going to get larger the larger the price is, whereas the demand's actually going to get smaller the larger the price is. So if we want these numbers to actually even out, we need to increase the price. So we need to increase the price to try to make this supply and demand match up a bit better. So what is the equilibrium price? So we want the equilibrium price. So we would want to set these two equations equal to each other. Now, how do I want to phrase this? So these two equations are given in terms of P. So they're Q equals, I missed my 3. So in this case, it's actually going, whoops, that should be a P back there. In this case, it's actually easier to solve for the equilibrium price first. It's always easier. Maybe I should avoid the word easier. More convenient. It's always more convenient to solve for the variable that's not already solved for. So it's actually easier to solve for that other value. So finding the equilibrium price is going to be more convenient, and then we'll be able to use that to find the break-even quantity. So it was kind of the opposite in the last question that we did, but that was because it was in terms of quantity instead of in terms of price. So finding the break-even quantity was more convenient. Sorry, yeah, no, that was break-even. I said the right word. So here we want to set these two equations equal to each other. So I would add that 500 over to the other side. 1100. Divide both sides by 1100. We'll get P equals 30. So just to put the units on there, that'll be $30. So to actually make these two values equal, the price needs to be $30. What's the break-even quantity? In this case, this is where we will take that price we just found and we can plug it back into either of the two equations, whichever one makes you happier. Because the point is that they should be equal at those 2 points, so at that point, so it shouldn't matter which function you plug it into. I'm going to plug it into, which one was that, supply? Yeah, just the one that doesn't have the subtraction, is it? So I would personally plug it in to this function. That's because it looks a bit nicer and has less steps. That would produce 18,000. You will get the exact same answer if you plug it into the other function. If you plug in 30 to the other function, you will also get 18,000. So this means that the break-even quantity, sorry, I was about to write a dollar symbol, 18,000, and we're not really told what this is, so we'll just say units. We don't know what kind of things they are, so we'll just make it generic. So what this means is that essentially the best case scenario is to make these things cost $30 and you'll be able to sell 18,000 of them, assuming that everyone who said they were going to demand them actually goes out and buys one. But that's kind of the point of the equilibrium point. Is kind of the best case scenario because you won't have any things left over. You won't have people who want one but can't get one. It's kind of the best of both worlds. And we don't know, this doesn't, let me clarify, this doesn't tell us anything about how much money we've made, how much profit there is, or anything like that. It doesn't take into account that. It's just if we want supply and demand to be equal, which is usually a pretty requested scenario, this is what we would need. Any questions, concerns on that? Okay. I believe our next question is a bit long. It's the last question we have, but it's a bit hefty. Actually, wait just one moment. Ooh, we should do this first part because I think there's a one on your homework that is similar, so I would want to do this one. So I was going to save all of problem 5 for next time, but let's just do this first part because it'll appear on your homework. I think, if I'm remembering correctly. So, Anne-Marie's love of dogs inspired her to create the perfect dog biscuit and start up a business to share them with the world. Through market research, she found that at a price of $5, she was able to sell 10,100 biscuits, and that every decrease in price by 50 cents would increase the number of biscuits sold by 2772. Assuming this relationship between price and quantity is linear, what is the demand function Q in terms of the price P? So Q in terms of P would be Q equals F of P. So if you ever see the word like in terms of the words, this is almost equivalent to saying is a function of. So essentially Q is in terms of price. Q is a function of P. So what we need to do here is we're assuming it's linear, so we need a slope and a y-intercept. What we're told in this question is a slope and a point. So the point we're told is that it's going to be $5, gets us 10,100 biscuits sold. And now if I want to find out the slope would be a change in Q over change in P, which we're actually told. Notice that here where it says every decrease in price by 50 cents would increase the number of biscuits sold by 2772. So the change in Q, the change in the quantity of biscuits, would be 2772. And the change in price is a decrease of 50 cents. So we have negative 0.5 or 50 because I'll just write it because it makes more sense because it's cash. Which will give us a slope of negative 5,544. Whoops. So we have a slope and we have a point. So if we want an equation of a line, we can now use those two things to find the B value. So we have that the Q was 10,100. M was negative 5544. P was 5. And we don't know what B is yet. That's what we want. So we will have 10,100 equals negative 27,720 plus B. Add the 27,720 over to the other side. We'll get 37,820 as the B value. So the demand function will be, whoops, well, I guess it doesn't matter which one we put first, but I usually put the slope first. So negative 5544 P plus, am I going to run out of space? Did it. So that would be our demand function in terms of price. And then actually I do want to do part B real quick. Part B is very quick. Part B says use your answer in part A. Because, okay, your answer in part A gives the total number of biscuits that she will sell based off of the price. Express the total revenue that she will make in terms of the price by substituting your answer in part A to the general equation for revenue, R equals P of Q. So you won't always be reminded that revenue equals P of Q, which is why you should remember it. But in this case, they're kind of being nice and reminding us. But essentially all we need to do is we have that revenue. So this is going to be in terms of price because our quantity is in terms of price. Actually, it would be R of P. So price times quantity. And essentially we leave that first price, but this quantity here, this Q value, is going to be replaced by that entire function that we just found. And then usually it's good to just push through that P value and distribute it to both to get negative 5,544 P squared. plus 37, 820p. And then now we'll leave the rest of the question to later, because I don't think that will appear on your homework, but I do believe that there is one like this where you have to find the demand equation. So if you have any questions, feel free to stick around. Otherwise, we're done for the day, so I will stop the recording. I hope you have a great weekend. I will see you on Monday.